Task number 2, DHCP. Give me my network settings. You went to your favorite coffee shop, grabbed your favorite hot drink, and opened your laptop. Your laptop connected to the shop's Wi-Fi and automatically configured the network. So you could now work on a new Try Hack Me room. You didn't type a single IP address, yet your device is all set up. Let's see how this happens. Whenever we want to access a network, at the very least, we need to configure the following: IP address along with subnet mask, router or gateway, and DNS server. Whenever we connect our device to a new network, the above configurations must be set according to the new network. Manually configuring these settings is a good option, especially for servers. Servers are not expected to switch networks. You don't carry your domain controller and connect it to the coffee shop Wi-Fi. Moreover, other devices need to connect to the server and expecting to find them at specific IP addresses. Yep, so in other words, your laptop needs to be mobile, let's say. Needs to be dynamic. But a server, let's think of a server in terms of a bigger computer, a heavier computer that takes much more space, needs to be static. Also, it's important to, for the sake of this conversation, to have a specific IP address. Having an automated way to configure connected devices has many advantages. First, it would save us from manually configuring the network. This is extremely important, especially for mobile devices. Secondly, it saves us from address conflicts. That is when two devices are configured with the same IP address. An IP address conflict would prevent the involved host from using the network resources. This applies to local resources and the internet. The solution lies in using Dynamic Host Configuration Protocol, DHCP. DHCP is an application level protocol that relies on UDP. The server listens on UDP port 67 and the client sends from UDP port 68. Your smartphone and the laptop are configured to use DHCP by default. Discover, offer, request, acknowledge, DORA. DHCP follows 4 steps: discover, offer, request, and acknowledge, DORA. DHCP discover, the client broadcasts a DHCP discover message seeking the local DHCP server if one exists. DHCP offer, the server responds with DHCP offer message with an IP address available for the client to accept. DHCP request, the client responds with DHCP request message to indicate that it was accepted the offered IP. And then the DHCP acknowledge, if you remember from the DHCP handshake, the server, the server responds with a DHCP pack message to confirm that the offered IP address is now assigned to the client. The same, if you remember from the previous room, on the TCP handshake, three-way handshake, is the same diagram used, but now we display with the same diagram the DHCP configuration. From our laptop to the server, we request a DHCP discovery. The server responds to the offer. Then we send back our request and then we send the pack. The server sends the pack. The following packet captures show the 4 steps explained above. In the example, the client gets the address, the following address. And here we see with Wireshark, with T-Shark, which I presume is a command line tool like Wireshark, we use the DHCP protocol. I presume this is the logic of this command line display. I never use this one, but it looks like that. It's just the display for the 4 steps above, and also the display from the illustration above. The DHCP packet exchange, we can notice the following. The client starts without any IP network configuration. Also, it only has a MAC address. In the first and third packets, DHCP, discover, and request, the client searching for DHCP server still has no IP network configuration and has not yet used the DHCP server's offered IP address. Therefore, it sends packets from the address 000 to broadcast IP address. Exactly. Here and also here. As for the link layer, in the first and third packet, the client sends a broadcast MAC address, right, not shown in the output above. The DHCP server offers an available IP address along with the network configuration in the DHCP offer. Over here, it uses the client's destination MAC address. It uses the proposed IP address in the example system. At the end of the DHCP process, our device would have received all the configuration needed to access the network or even the internet. In particular, we expect that the DHCP server has provided us with the following: the least IP address to access the network server resources, the gateway to route our packets outside the local network, and a DNS server to resolve the domain. More on this later, yeah. So domain resolution DNS needs to be placed on a later thought. We will touch on that later. So basically, DHCP is the protocol to auto-configure your network. Answer the questions below. How many steps does DHCP use to provide network configurations? Bam, bam, bam. 1, 2, 3, and 4. What is the destination IP address that the client uses when it sends a DHCP discover packet? Packets from the IP address 0000 to the broadcast IP address 255.255.255.255. So, boom. What is the source IP address a client uses when trying to get IP network configurations over DHCP? You see it over there. It's 0000.